Dr. E.N.G. Marek Gruszecki. Philosophy of Being. Krakow, 2025. My 85th anniversary. Philosophical essay Does God Exist? Krakow, the 19th of April 2025.
Secrets of the Cosmos, Part 1. Many people wonder whether the stars matter to us. In the universe, without stars there would be no life, and neither would we. Firstly, stars produce the energy necessary for life. Just as importantly, the basic elements necessary for life are created inside the stars. We are all children of the stars. The universe was created almost 14 billion years ago by the Big Bang. During all this time, it has been constantly expanding and changing. In the beginning, the universe was very small, very hot, and very dense. Part of the released pure energy became dense and matter was created. Space began to swell, carrying matter with it. Space expanded and the universe cooled. The mysterious dark matter concentrated in bands with strong gravity, and a network of dark matter like a scaffolding was formed, and ordinary matter clustered at the nodes of this network. Gravity gradually attracted the matter, forming the first stars and the first galaxies. The universe is only about 5% made up of known forms of matter and energy. The rest is mysterious dark matter and even more mysterious dark energy. Dark matter is still a theoretical form of matter that makes up about 85% of the matter in the universe, but we do not know what it is made of. We cannot see it because it does not interact with light or ordinary matter. The only way to detect it is through its gravity. Dark energy, on the other hand, is supposed to fill all the free space of the universe and be responsible for its expansion. Will the universe always expand? The expansion of a universe is the swelling of space rather than the movement of whole clusters of galaxies. How is it possible that the universe is expanding faster than light? The speed of light is indeed the maximum speed in nature. However, the speed of light does not limit the speed at which space itself can expand. In other words, the structure of space-time can expand faster than light can move through it. Although the universe is infinite, we can never see it in its entirety. Because light needs time to travel, we can only see light that travels for at most 14 billion years. We call this spherical region the observable universe. The light of the galaxy we observe, as a result of the curvature of space-time by massive objects, can reach our eyes via different paths, from different sides of the sky. In addition, each of these paths has a different length, which means that the same object can be observed at different ages. Why does this happen? Because light has a finite speed. Secrets of the Cosmos, Part 2. Stars are formed in swirling clouds of matter. As a result of gravity, such a cloud begins to thicken and heat up. At some point, the temperature reaches millions of Kelvin. A thermonuclear fusion reaction takes place, producing helium from hydrogen. From this point, the cloud becomes a star. The internal pressure balances the force of gravity. After a certain time, the nuclear fuel runs out and the star explodes as a so-called supernova. In the explosion, heavier chemical elements are formed, which spread out into space as mists. Stars are like factories that increasingly enrich the gas-dust mist with the elements they produce. In the nucleus of a star, there is a kind of engine that fuses atoms together to form heavier elements. The heaviest that this process can produce is iron. Most chemical elements were formed by stars over a period of millions to billions of years. At the end of their lives, thanks to planetary nebulae and supernova explosions, stars scatter the elements they produced. Such a cycle occurred many times before the solar system with the sun and planets was formed. The solar system was formed about 4.6 billion years ago and is associated with the thickening of a swirling cloud of matter. Most of this matter concentrated in the center to form the sun, which, when it reached a large enough mass and temperature, ignited. It became a star. The planets formed from the solar nebula, a cloud of gas and dust made of small grains, in the shape of a disk orbiting the sun. As a result of mutual collisions, these grains began to form larger and larger objects. The original nuclei of the rocky planet stopped accumulating matter about 100,000 years after the formation of the sun. Their further growth to their present size took place as a result of subsequent collisions and mergers in a process that may have taken up to 100 million years. Eventually, the 4 rocky planets of the solar system were formed. It contains elements formed in previous generations of stars. Groupings of stars develop into galaxies, and there are millions of galaxies, and they form higher-order structures called groups, clusters, and superclusters of galaxies. However, the very distribution of galaxies and galaxy clusters raises many questions. Why are there very many galaxies and clusters in some places and empty areas in others? Dark energy is a hypothetical form of energy that would explain the observed acceleration of the expansion of the universe. Unlike dark matter, which acts as a glue that holds galaxies together, dark energy acts as a repulsive force that causes the expansion of the universe. The universe is something unimaginably vast and even completely beyond our comprehension.
Conclusion. But Jesus, overhearing what was being said, said to the ruler of the synagogue, "Do not be afraid, only believe." Bible, Mark 5 verse 36. It will still be beautiful, despite everything. Just put on comfortable shoes, because you have your whole life to go through. John Paul II. Mathematics in Nature.